Hey everybody, Dr. B here. Welcome to week 4. Gosh, we are already 1/5 of the way through the semester. And I just wanted to share with you a few things about color vision today. Now, if you're in my intro course, our chapter this week is Sensation and Perception, and as you'll see, we talk a lot about vision in that chapter. If you're in my psychobiology class, we actually skipped those 2 chapters on sensation and perception, largely because we have a whole course on sensation and perception, which I also occasionally teach. So if you have not taken that already, I would love to see you in that course someday. That applies for all of you. All right, so I wanted to just share with you a couple of weird things about seeing color. So that's my greeting for you this week. All right, so we take a look sometimes at illusions in this chapter when we cover vision. And I want to share with you one that the most amazing illusion of all, at least for me. All right, it's really a simple, basic one. And if we were in a classroom, it would be much more easy for me to just, demonstrate this one for you. But so I'm going to require you to use your imagination a little bit. So you've all been in classrooms with one of these, a projector screen. Now, humor me, what color are those screens? They're always white. All right, maybe a little off-white. They're white. All right, so. The most amazing illusion for me that I want to get you to think about right now is seeing black on a white screen. All right, so we take a projector, and all of these projectors that are commonly in classrooms all work by projecting red, green, and or blue lights. That's all that's inside those. They can project red, blue, and green light, and that's it. All other colors that we can perceive can be made with combinations of red, blue, and green light, okay? So just bear with me on this thought, example here. So if I shine all the blue lights at once, it'll fill up the screen with blue, and you'll see, not surprisingly, it'll appear to be blue. Likewise, if I turn on all of the green lights in it, the whole screen will fill up with green, and it'll look green. Turn on the red lights and then it can shine red. All right, so now I can shine other combinations of these colors. If I were to shine red and blue, you'll see purple. And if I shine red and green, oddly enough, perhaps, you'll see yellow. Okay, so if yellow is being projected on a screen from one of these systems, and then your device, whatever you're looking at right now, works similarly, by the way. Instead of a white screen, you're looking at something that's by default, it has a black screen. But all of the individual pixels that project on your device are red, green, or blue. All right, so when you see yellow on the screen, there is no yellow light being projected out of your screen. It's shining red and green so close together that you see yellow. You're going to see described in just a few minutes. All right. So anyway, back to my most incredible. These are all neat phenomena by themselves. We're going to see and explore in just a second here. But again, back to for me, what the most interesting thing is this. All right. So imagine that you're back in the classroom, and I project a black square on the screen. All right. Now, think about that. There's no such thing as black light. You've probably heard that term, black light. It's really a kind of blue, ultraviolet kind of light. But there's no black bulb, all right? There's no black beam coming out, projected on the screen. What's going on there? The projector is shining, for the rest of the screen, it's projecting all 3 red, blue, and green lights. And red, blue, and green light projected simultaneously in equal amounts produces the phenomenon of white. You see it as white. So it's just basically lighting up that already white screen, and it's just making it, well, white. All right? Now, where the square is, the black square is, it's just not projecting anything. Okay? So that's think about that, what's happening when you're looking at that black square. That black square isn't being projected onto the screen. That screen underneath there is white. It's always white. The screen doesn't change color except when something's projected onto it. All right, so no light or less light is falling on that square, and your brain is perceiving that as black. I think that's just a really amazing phenomenon. You're looking at a white screen and it looks jet black. All right. Now, that's not really amazing on the device you're looking at right now, because on whatever device you're looking at, laptop, cell phone, whatever you're using right now, that is already a black screen. So it's not quite the same phenomenon. So you have to imagine being in the classroom with a white screen, and you're looking at that, light being projected onto it and falling onto this white screen in different amounts, and you see jet black on something that is white. Okay, that to me is an amazing illusion. Okay, so here's another one I want to show you. So I'm not going to trick you here. I'm going to show you these two pictures sequentially here. I'm not going to show you any other photo. It's going to be one of these two photos, but in a moment you're going to see something very different than these two photos. And I promise you, I'm not going to fool you. I'm not going to project a third photo. Your brain is going to produce the third photo. All right, so I'm going to show you these. Here's what I'm going to do. Show you this one first. All right. So this takes almost a minute. All right. So get comfortable, and I want you to stare at the center of that butterfly and don't look away. All right. So look there and watch the counter count down. It's going to count down by 5. Don't look away. Keep looking at the center there. Don't look at anything else. Okay. 35 more seconds. Just keep staring at that. Don't look away. All right. Now, if you promise not to look away, I'll tell you what's going on there. Just watch those numbers, count them down. All right. And your cones in your retina and your eyes are being saturated by these odd colors. All right. So 15 more seconds. Don't look away. Now, in a moment, that is going to shift to the black and white image. Keep watching. Don't look away. Keep looking at that same spot. Don't look away. Don't look away. Keep staring at that. And don't look away. The moment you look away, that color image vanishes and disappears. All right. So by now you've probably looked away, or the image is faded, and you can see that it's just a black, white, and gray image. The other one that I showed you before. All right. So amazing illusion there. Color after image that happened there. Okay. So anyway. At another time, I might tell you more about this and tell you another related phenomenon associated with that. But anyway, great example of a color after image. I'm sure for a moment you were convinced that I had projected a normal color monarch butterfly with a blue sky. And if you don't believe me, just replay the video and watch that and do it again. All right. So I'm going to close with this last amazing example and a video coloring it. Okay, so I want you to stop and think about something really amazing that, if you've never heard this before, this is going to blow your mind. All right, so I just got done saying earlier that red, blue, and green lights can produce millions of different colors that we're capable of seeing. All right, but one color is very mysterious, and that's magenta. It's similar to purple. It's a little bit different, okay? I don't know how to explain the difference between purple and magenta, but there's slightly different colors here. But magenta, in a real sense, doesn't exist. And this video is going to explain to you exactly how and why you're capable of seeing magenta, a color that should not exist, okay? So watch this, enjoy, and prepare to have your mind blown. All right, so I'll just end this when this is over. So enjoy, have a good week, hit me up with any questions, and I'll see you next time.
The world is full of colors, some vibrant, some dull, and some that are all in our heads. In fact, you are looking at a color on your screen right now that, in a sense, doesn't exist. Unlike virtually all other colors, there is no wavelength of light to describe it. but we see it anyway. It's magenta. And it is nothing but a trick from your brain. Our eyes can see things because in the back of the eye there are millions of receptors called rods and cones. Rods are sensitive to light intensity and movement, while cones are the receptors that see color and fine detail. There are all kinds of cones out there in the animal kingdom, but humans have 3 types of them. One that detects long wavelengths, like red light, one that detects medium wavelengths, like green light, and one for short wavelengths, like blue light. When light enters the eye, it causes some of these cones to fire depending on what wavelength it is. So if you're looking at a red apple, your long wavelength cones might fire, or if you're looking at the sky, your short wavelength cones, or blue cones might. But as you might have learned or noticed, there are more than 3 colors in the world, so how do we get by with only 3 types of cones? Well, our eyes kind of cheat, because while each type of cone is most sensitive to a specific color, they actually respond to a range of wavelengths, and most importantly, those ranges overlap. So say you're looking at something yellow. On the visible spectrum, which is the range of wavelengths we've assigned colors to, yellow is between green and red. So if you have typical color vision, when you see a yellow object, your red cones fire a little and your green cones fire a little, but your blue cones have no stimulation. Your brain interprets that unique pattern and knows whatever you're staring at must be something in between red and green, so yellow. Something similar happens when you're looking at cyan. In that case, both your green and blue cones fire because cyan is in between green and blue. But what happens when you look at an object that makes only your red and blue cones fire? At first you might think you'd see green, since on the visible spectrum, that's the color in between red and blue. But remember, your green cones aren't firing. So what does your brain do? It makes up a color! And this is what we see as magenta. Unfortunately, it's hard to say exactly why our brains make up this specific color. Like, there's nothing that seems to be particularly special about magenta, but we see it anyway on everything from billboards to t-shirts, and that is really weird. I mean, pretty much all of the other colors we see have one specific wavelength we can use to describe them. But that's not true of magenta. The color is nowhere to be found on the visible spectrum. It's just the odd way our brains happen to respond when hit with red and blue light. This makes magenta what's called a non-spectral color, a color that can only be described by combining multiple non-adjacent wavelengths of light. It sounds bizarre, but our brains do this sort of thing all the time, processing the world in strange ways to help us make sense of all of the weirdness around us. And hey, if it gets us a nice color like magenta, it can't be all that bad.